All right. Yes, we can now start with the topic called as time value of money. Now, time value of money, this is the topic which is not there in CA final SFM, but believe me, most of the formulas of CA final SFM got derived from this area called as time value of money. I know it is there in CA foundation, but I hope you all left this particular topic in CA foundation as choice if you come from CA foundation. Okay, so done. Let me now discuss time value of money. Though it is not there in the syllabus, I am discussing. The reason for the same is it is so important for understanding the concepts of, okay, or formulas of CA final SFM. For that reason, I am not taking it as choice. Time value of money, okay, is the most precious chapter to start with CA final SFM. CA final SFM, the first and foremost topic which we need to listen to in this particular area is called as time value of money. Let us now talk about something which is really important. Now you answer me few things. If you invest, okay, some money today, okay, it will be accumulated with interest after 1 year or 2 years, okay, for that matter. Okay, so what I'm trying to say, believe me, if you invest 100 rupees today, maybe after 1 year it shall be more than 100 rupees or not. Okay, it shall be more than 100 rupees. What is the difference between this and this? There is only one part called as interest. So today's 100 rupees will be added with interest to give you more than 100 rupees after 1 year, for that matter. Okay, so it may be more than 1 year also. I am taking it as 1 year. Okay, for that matter, I am just going to third class or fourth class, where we used to study one formula called as interest. I is equal to PTR, okay, PTR percentage. What is I? I is nothing but interest, where P is nothing but principal, time, and R is nothing but interest rate. Now, if you keep principal of 100 rupees today for 1 year, into R percentage, let me take 10 percentage. So I is equal to 10 into 1 into 10 percentage gives you 10 rupees. Okay, now this principal 100 rupees added with interest will give you 110 or not after 1 year. Okay, so how can I write this 10 rupees? 100 plus 10 can be written as, okay, 100 into 10 percentage, 100 into 10 percentage, which is equal to 110. So out of these two, I can take 100 as common figure and I can write it as, okay, 1 plus 10 percentage here, 1 plus 10 percentage, which is equal to 110. Now what is 100 rupees? 100 rupees is nothing but present value, okay, and 1 plus 10 percentage is nothing but R percentage, which will give you 110. So this 110 that we are going to receive after 1 year, hence I named it as future value. Now can I write like this? Present value into 1 plus R percentage is equal to future value. Okay, future value. Today's 100 rupees, when it is compounded at R percentage for 1 year, okay, it may give you future value. It will give you future value. Okay, for that matter. Okay, it will give you future value. Also, I can write this formula as future value is equal to, okay, or present value is equal to future value divided by 1 plus R percentage. So after looking into these two terms, term number 1, and from that term itself I have derived another formula called as, okay, present value is equal to future value divided by 1 by R percentage. Let us now make an analysis of term number 1. So when you multiply two figures, present value into 1 plus R percentage, when you multiply two figures, automatically the result will be, okay, something which is more. So when you multiply two figures, it is called as compounding. So when you compound present value for 1 year at R percentage, then it will give you what? Future value. That 1 year may be 2 years or 3 years, or it may be 4 years also. So it will be given in the question. Okay, done. So can I write a sentence for the same? present value when it is compounded at r percentage for for a given period n number of years, it may be 1 2 3 or more than 10 15 20 anything. Present value when it is compounded at r percentage for n number of years, it gives you what? Future value. Hence we can write it as future value is equal to present value when it is compounded, which is nothing but 1 plus r percentage. This is the formula, and if it is for 1 year the power will be 1, if it is for 2 years power will be 2 and 3 4 5. So I can remove everything and write here as n. Future value is equal to present value into 1 plus r percentage power n. So let me write one thing. Let me take one small example. 100 is the present value. Where you need to compound at r percentage, but that is equal to 10 percentage, and the given number of years will be, imagine it is 5. Now how to calculate? It is asked in the question that calculate future value. So the formula will be future value is equal to present value into 1 plus r percentage, power n. Present value which is given in the question, that is 100 rupees, plus 1 plus r is also given 10 percentage. 10 percentage will be calculated in such a way: 10 divided by 100, 10 divided by 100, which will give you 0.1. 0.1, power n will be 5. So 100 into 1.1 power 5. 1.1 power 5 also can be written as 100 into 1.1 into 1.1 into 1.1 into 1.1 into 1.1. This term shall be calculated first of all. This 1.1 into for 5 years, this shall be calculated first of all. How to calculate this figure using calculator? This is one first calculator technique which we need to understand. Now press 1.1 in your calculator. Type multiplication symbol twice. Press equal to. 2 times multiplication it has been done till now. 2 times multiplication, 1.1 into equal to, it will become 1.21. 1.21. 2 years are been done. Now 3 4 5. Then the answer will be 1.61051. So I can write it as 1.610, which will be equal to into 100, which will become 161.051. This is the value. This is the future value. So now the question is, if you keep 100 rupees in a bank today at 10 percentage for n number of years called as 5, then the future value will become 161.051. This will be the answer. How did I calculate? Again I am repeating the same. 1.1 into 2 times multiplication button you need to press, into, then equal to. So when you press equal to for the first time, it got calculated twice. So 2 years are been done. Now 3 4 5, the answer will be 1.61051. This is how we need to calculate future value. It is for 1 year or 5 years, or it may be for 15 years. This is the same process you need to follow. I guess you are all getting the point. Very clear. With this, using present value, can I calculate future value? Yes, it is possible. Just now I have proved. Now let us talk about using future value. Can you convert that into present value? Is it possible? This is the second example I am going to take. Now same question, I am changing it now. After 5 years you are getting the future value. After 5 years you are going to get 100 rupees at r percentage 10. R 10 percentage, and n is equal to 5. So after 5 years you are going to get 100 rupees. Now what is the value of that 100 rupees today? Okay, this is what you are going to answer now. After 5 years you are going to get 100 rupees. How to convert that future value into present value, that is the question. That is the question. Okay, now you know the formula of present value. Present value you are going to calculate, hence present value is equal to future value divided by 1 plus r percentage power n. Okay, so this is also can be written in a sentence. Future value when it is discounted, future value when it is discounted, it gives you present value. Future value when it is discounted at r percentage for n number of years will give you what? Present value. This is the formula for the same. Now in the question it is given as 100 rupees divided by 1 plus 10 percentage power 5, which can also be written as 100 divided by 1.1 power 5. 1.1 power 5. How to calculate in the, okay, using this calculator, sir, how to calculate this figure? Okay, denominator 100 divided by denominator I am going to calculate now. Okay, this denominator, in fact it is not denominator. Okay, you can write this as 100 into 1 divided by 1.1 power 5. Okay, the entire figure 1 divided by 1.1 power 5 I am going to calculate in this way. Okay, now 1 divided by 1.1 equal to, okay, one time I pressed, 2 3 4 5 times I pressed. Okay, 5 times. This is called discounting factor. This is called as what? Discounting factor. What is the discounting factor for 5 years? 0.620. 620 will be the discounting factor for 5 years. Hence into 100 will give you 90.9. 90.9. Okay, this is the value. This is the value. See, 1 divided by 1.1 equal to into 100. It is not 90.9. It is what? It is 62.09. 90.9 is nothing but a 1 year discounting factor. Okay, now 100 into 0.620 will give you 62.09. Okay, this is the answer for present value. Future value, if it is 100 rupees after 5 years, how to calculate the present value? This is what we have seen till now. Okay, using the formula and a simple calculator technique. Okay, I hope you are all getting the point very clear. These are the two basic formulas that you need to understand, and these two are called as single cash flows. These are called as what? Single cash flows. Sir, how did it become single cash flow? See, in both the examples there is only one cash flow. Today if you deposit 100 and check after 5 years, or after 5 years you are going to get 100, and what is the value of that 100 rupees today? It is only the single cash flow that you are depositing or getting in those two examples. For that reason it is called as what? Single cash flow. And using single cash flow, I converted present value to future value and future value to present value before you till now. Okay, now the other aspect of time value of money. Okay, the other aspects of time value of money, and that is called as what? Multiple cash flows. Okay, multiple cash flows, which are very important for our understanding purpose. Multiple cash flows. Sir, what is called as multiple cash flow? Multiple cash flow, maybe it is divided into two types. One, it is annuity. The second one, it is others. Okay, so for the time being I am not going to discuss this others. As and when we encounter any situation, any question, okay, going forward, then only we'll be discussing this particular area called as multiple cash flows others. Let us now discuss about multiple cash flows annuity. Multiple cash flows annuity. Sir, first of all, what is annuity? Annuity is nothing but a similar cash flow, or also we can call as equal cash flows. Equal cash flows are received or paid. Okay, equal cash flows are received or paid with equal time gap. With equal time gap. Okay, this is called as what? Annuity. Let us take one small example. Today you deposited 100 rupees. Today you deposited what? 100. In the first year you deposited 100 rupees. In the second year also you deposited 100 rupees. In the third year also you deposited 100 rupees. See, year number 1, 2, 3, 4, 5. Okay, year number 1 you deposited how much? 100 rupees. Year number 2 you deposited 100, 100, 100. Okay, so every year the deposit is been done. So these are called as multiple cash flows, and you, if you observe the same, okay, see, each and every cash flow will be 100 rupees, which is same, and the difference between each cash flow, the time period between each cash flow is 1 year only. The difference between first year and second year will be only 1 year, and 1 year, and 1 year, and 1 year. Okay, I hope you're all getting the point clear. So multiple cash flows, in that annuity I am discussing about. What is annuity? Annuity is nothing but multiple cash flows, that two equal cash flows happening with the same time gap between each cash flow. Now this is called as what? Annuity. Now in the question it may be asked as, if you deposit 100 rupees every year for 5 years, okay, then what is the ultimate value after 5 years? The ultimate value after 5 years, the future value after 5 years. Present value they are giving every year, and they are asking you to calculate future value after 5 years. This is the question I am going to discuss now. Okay, I hope you are all getting the point clear. So let me write it clearly, okay, much more clear, because these are the aspects we need to understand carefully, and all the formulas and all, it shall be over the fingertips. Okay, so let us now try to understand this area. Now year number 1, 2, 3, 4, 5. Okay, year number 2, let me take one small example. Year number 6, 7. Year number 6, 7. There are 7 years where there is a cash flow of 1000 rupees. Okay, every year cash flow will be how much? 1000 rupees, 1000 rupees, 1000, 1000, 1000, and they ask you to calculate what? The future value. And imagine there is an interest rate. Okay, there is an interest rate 10 percentage. What is our percentage? 10 percentage. So now we need to calculate compounding factor for the same. Compounding factor, today if you deposit 1 rupee, what will be its value after 1 year? What will be its value after 2 years? That is what we are going to calculate. Now let us now try to understand one thing. In the 7th year, last day, if you deposit 1000 rupees, what will be the value of that 1000 rupees on the day itself? What is the factor with which we need to multiply? If you deposit 1 rupee on 7th year last day, okay, what is the value of that 1 rupee at the end of 7th year? 1 rupee will be 1 rupee only. There won't be any compounding factor at all, because as on that day you invested and you are checking. So the compounding factor for the last year will be 1. Last year, because 7th year last day I deposited, I am checking again. So there won't be any interest factor which will be added. So 1 rupee will be equal to 1 rupee only. Okay, so 1000 rupees will be equal to 1000 rupees only. So 1000 into 1 will give you what? 1000 only. Now 6th year ending, you are depositing, okay, 1000 rupees. Now what will it become after 1 year? That is 7th year ending. That is 7th year ending. So what will it, what, okay, it will become? That is the question. If you invest 1 rupee at the end of 6th year, and if you check after 1 year at the end of 7th year, 1 rupee will become 1 into, see, 1 rupee will become 1.14. 1.14. That is what, okay, compounding is all about. 1 will become 1.14 at our percentage. Okay, 1.14. So the compounding factor for 1 rupee for 1 year is 1.14. 1.14. For third year, like if you deposit 5th year ending, from 5th year you need to go to 6th year. From 6th year you need to again go to 7th year. So for that reason, here I can write it as 1.4 into 1.14. 1.14 into 1.14. Okay, 4th year, 1.14 into 1.14 into 1.14. because 4th to 5th, 5th to 6th, 6th to 7th, 3 times compounding we need to do, and for that matter, okay, it is 1.14 into 1.14 into 1.14. Okay, in the similar way, 1.14 into 1.14 into 1.14 into 1.14, like that we need to repeat till, okay, year number 1. See, what if on year number 1 last day, if you deposit 1 rupee, year number 1 to 2 one time, 2 to 3, 3 to 4, 4 to 5, in that way we need to do till 7th year. Okay, so I guess you are all getting the point clear. Okay, these two you can just write, or also I can just copy. See, 1.14 into 1.14 into 1.14 into 1.14 into 1.14. Okay, again 1.14, very very important for understanding purpose. 1.14 into 1.14 into 1.14 into 1.14. Don't calculate using calculator. I'll be, okay, telling you one technique. So very very important technique. 1.14, 1.14. So 1 2 3 4 5 6. Now to get the answer, you need to multiply this 1000 with this entire figure, and this 1000 with this entire figure, this 1000 with this entire figure, and you need to write everything here. Okay, then you can add up and you will be getting the future value. This is the question. Imagine a case where if it is given for 20 years, how difficult it is to calculate 20 years compounding factors, because every year when you are investing, okay, every year the multiple cash flows when it is invested, so there will be some technical difficulty in calculation using this calculator. For that matter, we can just simplify using a formula, using a technique in this calculator. Now you tell me one thing. Okay, each and every, like, second column, this second column, every figure will be same. Every figure is same. Okay, 1000. So from every, okay, figure you can just take out 1000. See, to calculate this blank, you need to multiply second column with third column. Now in every second column we have same, okay, value called as 1000. When you take out 1000, okay, when you take out 1000, then only the remaining figure will be all this 1.14 into 1.14, like that. So you need to add up everything. First of all, how to add this, okay, this huge series of numbers, how to add up this huge series of numbers using the calculator, now, okay, write down there is a technique. So first point, we'll start from the below, okay, it is 1. Type 1 in your calculator. Type 1, press m plus, okay, press m plus, okay, again type 1.14. see this one, okay, so 1.14, again press m plus, 1.14 m plus, okay, into 1.14 into 1.14 equal to, okay, into 1.14 equal to press m plus, how many times I pressed m plus? This is 1 2 3. So 3 years it got added till now. 3 years it got added, 1 2 and 3. Remaining years you need to just add. Remaining how many years are there? There are 4 years. For that matter, you need to just press equal to m plus, equal to m plus, equal to m plus, and equal to m plus for 4 years, remaining 4 years, and then add mrc. Okay, so equal to m plus, equal to m plus, equal to m plus, equal to m plus 4 times. Okay, total 7 years. Hence the answer, at last we need to calculate mrc, and then it will give you the answer called as 10.730. This is the compounding factor for annuity. This is the compounding factor for annuity. Hence we need to just calculate 1000 into 10.730. 0. This is the future value. This is the future value into 1000, which will be equal to 10,730. 10,730. So if you invest every year 1000 rupees for 7 years, then what will be the future value at the end of 7th year? The value will be 10,730. This is very important okay, equation where you need to remember till you complete your examinations. Okay, so whenever it comes, you must be aware of how to calculate this formula. Okay, this particular series of numbers using your calculator. Okay, I guess you're all getting the point very, very clear. Okay, I hope you're all getting the point clear. Done. Now, what did I just do? I just converted present value into future value. Present value to future value, that to multiple cash flows, that to annuity. Okay, that to annuity. So what will be the formula? Future value is equal to, because you are finding future value is equal to annuity value into compounding factor. Okay, compounding factor, or even you can call it as, okay, this can be called as future value annuity factor, also called as what? Future value annuity factor. So annuity value will be, okay, annuity value will be 1000. Every year you are going to deposit 1000 into future value annuity factor will be 10.730. This is what we just calculated using this calculator. Okay, hence the answer will be what? 10,730. This is how I derived the answer. Okay, I guess you are all getting the point very, very clear. Note it down very clearly, because this is the first chapter which is not there in the syllabus, as I am not required to, okay, in fact I am not required to discuss this. But believe me, without having the knowledge of the same, okay, you are not supposed to open CA final SFM at all. Okay, every formula will get, okay, into some linkage with these areas, and hence, okay, I just need to discuss this before I start CA final SFM topics. Okay, done. Now there is one more thing which is still pending. Just now I converted present value into future value, multiple cash flows. Now I just want to convert future value into present value. Future value into present value. Okay, that to multiple cash flows, that to annuity. Because as I said, okay, there is in the chart that others also. I am only discussing what? Okay, I am only discussing what? See this? I am only discussing this annuity figures. I am not discussing these others. Okay, in future we are going to discuss that whenever we encounter with that formula. Okay, later. So as of now I am talking about what? Future value to be converted into present value. To be converted into present value. That to annuity, multiple cash flows. So what may be the question? What may be the question in fact? So they are asking you, you are going to get, okay, you are going to get 1000 rupees every year. 1000 rupees every year for a period of 5 years. Imagine for a period of 5 years. Okay, so year number 1, 2, 3, 4, 5. For 5 years you are going to get how much? 1000. Okay, and the percentage will be 10%. Okay, then what is the present value of the same? Okay, all the future values are given, and it is asked in the question that to calculate present value. So after 1 year, if you get 1000 rupees, what is the value of that 1000 rupees today? Okay, then you need to calculate discounting factor for the same. If you are going to get 1 rupee after 1 year, what is the value of that 1 rupee today? That is called as what? Discounting factor. Discounting factor at what rate? Okay, discounting factor at what rate? 10%. How to calculate this 10%? See, 1 divided by 1 point, okay, 1 divided by 1.1, because you are discounting the same from, okay, from future you are coming to present, hence I need to discount 1 divided by 1.1, which will be equal to 0.909. So second year, another time you equal to, you need to press 0.828, 0.751, 0.683, 0.06, okay, 0.620, okay, done. Then so this is here cash flow, discounting factor, and discounted cash flows I need to calculate. So 1000 into 909.909, okay, 1000 into 0.909, okay, see, 909, 826, 751, 683, 620, 620. So if I calculate everything now, so what I am just doing, 1000 into 909 is equal to 909. So everything I need to add. So all I need to add up now. See, 909 plus 826 plus 751 plus 683 plus 620, that is equal to 3789. This is the answer for the same. However, every time we cannot calculate using this table, because since in the example I have taken for 5 years, if in the examination if it is given for 50 years, how to form a table for that, it is very difficult for you to calculate using that table. Hence we have to have the formula in our hands. Okay, since you need to check one thing, okay, that is the cash flow annuity or not. Let us now check annuity or not. Every year the cash flow is same. What is the cash flow? It is 1000, and time gap between each cash flow is same, that is 1 year. Hence it is called as annuity, and using that I can just calculate the value using the annuity factors. Now what is that I am going to calculate? Present value is equal to okay, annuity amount into present value annuity factor. Simply saying, out of all these values, 1000 is common. So 1000 into 0.909 plus 1000 into 0.826 plus 1000 into 0.751. So in this series of values I can take out 1000 as common, then remaining everything shall be added. So how to add all these things? Okay, using calculator technique I need to add up all those things. How to calculate, sir? 1 divided by 1.1 plus equal to, okay, plus equal to, which gives you 0.909, m plus equal to m plus equal to m plus. This is how you need to do for 5 years. See, 1 divided by 1.1 equal to m plus 1 year, 2, 3, 4, 5. After 5 times pressing m plus, press MRC, which will be giving you the value of 3.790. What is this 3.790, sir? It is nothing but present value annuity factor. So you are discounting everything and adding back. That is called as what? Present value annuity factor. The annuity amount will be 1000 into present value annuity is nothing but what? 3.790, which will be equal to 3790, which is almost equal to this table. This is how we need to calculate from future value, present value. So what are the formulas now? Can you say the formulas? Can you say the formulas? I am talking about what? Multiple cash flows. Out of multiple cash flows, 2 aspects are there, that is annuity, others. Am I talking about others? No, I am talking about what? Annuity. And you know what is annuity? Annuity is nothing but similar cash flows. Point number 1. Point number 2, similar is nothing but equal cash flows. And point number 2, equal time gap. When it is there, it is called as what? Annuity. Now we just need to observe conversions. Conversion, that is from present value to future value to present value. How to calculate future value from present value? Future value is nothing but annuity amount into future value annuity factor. Okay, this is the formula, future value annuity factor. How to calculate future value annuity factor, sir? Just now I have discussed, I have given a format for the same. Okay, m plus for the 7 tens, that is the example for the same. Now come to second aspect, where I need to calculate present value, which is equal to, present value is equal to annuity amount into present value annuity factor. How did I calculate present value annuity factor, sir? It is so simple, 3.790. That is the answer for the same. Just now I calculated 1 divided by 1.1 equal to m plus equal to m plus for the period of 5 years. Okay, then it will be giving you 3.790. The answer will be, okay, 3790. I hope you are all getting the point clear. This is how I just converted from present value to future value and future value to present value. Okay, so okay, this is what okay, I hope you are all getting the point very clear. The notes, okay, you can just copy simultaneously, because this is the chapter which is not relevant for okay, it is not there in the syllabus, hence I am not giving a detailed notes for you. Whatever I am writing, you can just make a pause for the same and copy the same. Okay, but it must be there on your fingertips. Okay, it must be, okay, 100% fit into your mind without looking into the notes. Okay, I guess I can go forward now. So what have we completed till now? In the time value of money, there are two aspects I discussed: single cash flow, multiple cash flow. Okay, for a single cash flow, conversion I have done, okay, using the formula present value is equal to future value divided by 1 plus r power n, or future value is equal to present value into 1 plus r power n. These are the two formulas I used for conversion. Okay, now out of multiple cash flows, I discussed annuity only for the time being, and in that I used what? Future value is equal to, okay, future value is equal to annuity into, okay, future value annuity factor. Okay, future value annuity factor. And second area, where present value is equal to annuity into present value annuity factor. Okay, these are the two aspects. Now observe one thing. In this annuity, there is one clear assumption I have made. Okay, one clear assumption. See, in that example, okay, the cash flows are received as on the last day of the year. Say in my primary example, okay, I got in the 7th year 1000 rupees. Okay, is it the first day of 7th year or last day of the 7th year I considered? It is the last day of the 7th year I considered. Okay, because of the same reason, since it is the last day, 1000 will become 1000 only, because there are no any, okay, number of days which are, okay, present there. Hence, the last day of 7th year, if you deposit 1000 rupees and check on that day, 1000 will become 1000 only. Hence, the compounding factor will be only 1. Okay, the assumption what I made is, okay, all these cash flows are, okay, made on the last day of the every year, last day of every year. These kind of cash flows are called as, okay, these kind of cash flows are called as regular cash flows. If the cash flows are happened on the last day of every year or last day of the year, it is called as what? Okay, it is called as what? Regular cash flows. See, cash flows got divided into two parts. If you have this cash flow of last day of the year, okay, or you can have other assumption called first day of the year. Now what is the example I have taken? I have taken the example of last day of the year, and that is called as what? And that is called as regular, okay, regular cash flows. These are called as what? Regular cash flows. If the cash flows are happened on the first day of the year, then this is called as, okay, immediate cash flows. Okay, immediate cash flows. I hope you are all getting the point very, very clear. Okay, so we completed regular cash flows. Now we need to see immediate cash flows only. Immediate cash flows only. Now, what is called as immediate cash flow? Let me take that example. Year, okay, cash flow, compounding factor, compounding cash flow. Year number 1, 2, 3, 4, 5. Okay. For that matter, it is 6 and 7 also in that example. Okay, 6 and 7 also in that example. Now you tell me one thing. Okay, so this is what 1000. Observe the formula very carefully. Okay, a simple thing I am just adding. Okay, see now you tell me one thing. In the 7th year, I am depositing 1000 rupees. In the 7th year, I am depositing what? 1000 rupees. On the first day or last day? It is on the first day. And I am calculating the figure on the last day. So if I deposit 1000 rupees on the first day of the 7th year, what is the value of the 1000 at the end of 7th year? Okay. At what percentage? In that example, it is, okay, at 14% if you remember. Okay. Now you tell me one thing. What is the compounding factor? 1 rupee will become 1.14 after 1 year, calculating from, okay, 7th year first day till 7th year last day. Now it will become what? 1.14. This is the compounding factor. 1 is going to become 1.14. Okay, I hope you are all getting the point here. Okay, for the 6th year, it will be 1.14 into 1.14. For the 3rd year, like 5th year, it is 1.14 into 1.14 into 1.14. Okay, write the same for all the years. Okay, see, 4 times, 5, 6, 7 times I need to multiply. Okay, 7 times I need to multiply. Now, if you observe the same example when I discussed, okay, previously with regular cash flows, how many times I compounded for this year? See, 1, 2, 3, 4, 5, 6. See, 6, 5, 4, 3, 2, okay, 1. See, 1, and last one is nothing but there is no compounding factor at all. Okay, it is just only 1. Now, if you observe the same, okay, there is one term which is, okay, making the difference between these two problems. Okay, here we started with 1, there we started with 1.14. Okay, here we are having 1.14, there we are having 1.14 into 1.14. For every year there is one difference called as 1.14. Okay, there is one difference. See, in this particular year also, see, the first year, in this year also, here there are 6 times 1.14, there is 7 times 1.14. So the only one term which is still the difference is 1.14. Okay, that we need to multiply. So the formula will be very, very easy, that when you want to calculate, okay, when you want to calculate future value for immediate cash flows, okay, you have to follow the same process whatever you follow, okay, for regular cash flows, and for that we need to multiply, okay, another one figure called as 1.14. How can I write 1.14? It is nothing but 1 plus r percentage. What is 1 plus r percentage? 1 plus 14%, which is equal to 1 plus 1.14, which is equal to 1.14. This is the figure I just need to multiply. Okay, now you tell me one thing. What is the formula for conversion of future value? Okay, conversion of present value into future value. Okay, for multiple cash flows, for annuity, that too immediate cash flows, not regular cash flows. It is immediate cash flows. Okay, it is immediate cash flows. The same thing what you need to remember is, okay, it will be calculated similarly how we calculated what? Okay, regular cash flows. What is the formula for regular cash flows? Okay, future value is equal to annuity amount into future value annuity factor. For how many years? Okay, in that example it is 7 years. 7 is equal to n. In the given question it is 7, that is equal to n comma r percentage. What is r percentage there? 14 percentage. Hence I am writing it as n comma r. Okay, so this is the formula we need to repeat for immediate cash flows also, but there is only one difference, that is called as what? Into 1 plus r percentage. We need to further, okay, multiply for the entire figure. If you multiply 1 plus r percentage for this figure, then it will give you future value annuity factor for, or future value for immediate cash flows. This is the only thing you need to remember. So now what is the formula? Immediate cash flows, if you want to calculate future value is nothing but future value is equal to annuity into, okay, annuity into, what is that we need to write? Future value annuity factor for n comma r percentage, okay, into 1 plus r, into 1 plus r. Okay, I hope you are all getting the point clear using the table. Okay, even if you do not understand any table, okay, you can just remember this formula 1 plus r. But since I discussed, okay, it will be so simple for you, okay, that to understand that this is the difference happened. Okay, for every term you need to multiply what? You need to multiply 1 plus r. For every year you need to multiply 1 plus r. Hence I calculated everything, okay, and I added everything and multiplied that figure with 1.1 plus r. Hence I am done with this conversion also, so let me write the chart now. Let us now finalize the chart. I started with what? Time value of money. I am repeating the same because of only one reason. Okay, these are the formulas you need to keep in your mind at any point of time. When someone asks you, okay, you need to raise your hand to answer the same. At any point of time it may be. Now, time value of money, single cash flow, multiple cash flow. Okay, again multiple cash flows, regular, and you know what is regular and immediate. Okay, so I'm not writing it again. Done. And again multiple cash flow, that too I'm discussing only annuity, others I'm not discussing. Okay, multiple annuity. So for single there are some conversion formulas. So from present value you can calculate future value, from future value you can calculate present value. So what are the formulas? PV to FV, FV to PV. Now you say it. PV to FV. Future value is equal to, since you are calculating future value, then the formula starts as future value is equal to present value compounding with 1 plus r power n. Okay, the second formula will be present value is equal to future value divided by 1 plus r power n. Future value, when it is discounted with 1 plus r power n, it gives you present value. Okay, we got to know the answer. Now you tell me, for regular it will be again divided into 2. For regular it will be again divided into 2. Present to future, future to present. Okay, present to future, future value is equal to annuity amount into future value annuity factor n comma r. Okay, n comma r. Second area, present value is equal to annuity into present value annuity factor, n comma r. Okay, done. immediate, again immediate, okay, again present value to future value to present value. Okay, this is the formula which is similar to this, okay. Future value is equal to annuity into, not future value, future value is equal to future value annuity factor n comma r into 1 plus r. Okay, there is only one thing which is left for discussion, that is immediate cash flows. Okay, immediate cash flows, future value to present value, immediate cash flows, future value to present value. Okay, this is what you need to answer. Okay, now this is the thing we are going to solve using problems. Okay, when we get problem, okay, then we'll discuss this immediate cash flow conversion from future value to present value. The formula starts with present value is equal to, okay, annuity into something we need to write, that we need to understand while we discuss the problem. Okay, as and when we have that formula, okay, we have that problem before we, okay, before we start the chapters. Okay, chapters or some formula, some problem when we encounter with, okay, then we'll be solving that particular area. So I hope you're all getting the point very clear. This discussion, I hope it is sufficient for our purpose. There is something which can be discussed, and but it is fine for the time being. I can just stop the session now. This is what we need to have some understanding relating to what time value of money. Okay, there is one another formula, okay, that is called as what, perpetuity, that we need to discuss in the chapter only, as in when we get the problem. Okay, in the chapter only, perpetuity. Done. So in the next chapters we'll be starting with valuation, bond valuation, share valuation, etc., where we'll be understanding the relevance of this area. Done. Okay, see you tomorrow with a new chapter. Done.